Okay, I used an uppercase R for this problem instead of the lowercase r as posted. There are a few ways to do this problem. Here's a circle with equation x squared plus y squared equals the radius squared. Right now I have radius set to a little bit more than 4 in this diagram. We have the hole with a radius of 1 millimeter. You might think we could just find the volume of the sphere, which is 4/3 pi r cubed, and then subtract the volume of the cylinder, but it's not really quite a cylinder because of this area right here, or that volume. So you could find the area of the cylinder and the area of, you could call this a cap. That's one way to do it. What I've decided to do is demonstrate how to do this with the shell method. So if we revolve this part of the circle about the y-axis, we will get a sphere with a hole in the middle, or it's sometimes called a bead. Okay, so the equation of this part of the circle is y equals the square root of r squared minus x squared. So the height of this typical shell is actually 2 of these guys. And the distance from the axis of revolution to the center of a shell is just x. So before I put these minus signs in here, the integral setup is 2 pi times the integral from 1 to r. That's where all these infinite shells are starting, times the average radius of the average radius times the height of the shell. And there's 2 of those square root of r squared minus x squareds. And now we can evaluate this integral by using u substitution. U is r squared minus x squared, so du is negative 2x dx. That's why I put these minus signs here. And we note that when x is 1, u is r squared minus 1. And when x is equal to r, u is equal to 0. So here's what we get after the u substitution. Negative 2 pi, the 1 becomes r squared minus 1, the capital R becomes 0. Negative 2x dx is du, and u to the 1/2. So the before I take the antiderivative, interchange the limits of integration to get rid of this minus sign. The antiderivative of u to the 1/2 is u to the 3/2 multiplied by the reciprocal of the new exponent, 4 pi over 3 u, which is r squared minus 1 right here. And then we could say minus 0 to the 3/2, but of course that's just 0. So there's your formula when the radius of the hole is 1. You could generalize this to say the radius of the hole is a little r, and this would be a little r squared right here. I think. Yeah. But anyway, here's the answer to part B. We want to know, when is the volume 200? So we just have to solve this equation for r by multiplying both sides by the reciprocal of 4 pi over 3, raising the result to the 2/3 power, adding 1, taking the square root. Okay. And here's what that looks like. If you get a decimal approximation, it looks like 3.7. I don't remember if that's a 0 or it looks like a 0. And here's kind of proof that that value of r for the radius will give us a volume of 200 cubic millimeters. Okay, there you go. Hope that helped. If you have any questions, post a comment.